So this is the first in a series of webinars that we plan to hold this year, and we aim to hold them at the rate of about one a month. And just to advise you that the next webinar will be by Roma Gwynn and Dave Chandler, and it'll be about biological solutions for sustainable crop protection, and it'll be on Tuesday the 20th of February at 4 o'clock. And there is already a sign up page, but I'll also send information around as well. So we have two speakers in this session. So we have Emilio Luminades, who's lead of the Agri-Tech development at WMG, which is the Warwick Manufacturing Group at University of Warwick, and Dave Chandler, microbiologist and entomologist at Warwick Crop Centre in the School of Life Sciences at Warwick. So the reason that we're holding this webinar is that the university recently announced the formation of Warwick Agri-Tech, which is to help the future of farming with automation, and basically it'll combine two world-class departments at the university, that's WMG and Warwick Crop Centre in the School of Life Sciences, and we'll be working with the High Value Manufacturing Catapult to spearhead automation in areas such as horticulture, other crops and forestry. So Emilio will kick off. We'll take questions at the end of each presentation, but please feel free to type questions in the chat as we go along. So I'll unshare now, and then Emilio, if you'd like to share your slides.
Sure. Okay. Am I sharing?
Yes, brilliant.
Okay, well, and thank you for this opportunity, Rosemary, to invite me to this webinar. It's very exciting for me to see so many people today that is interested in this topic. I think Agri-Tech has growth the last years, and how we will be capable in the university and other organizations to make it happen is a big challenge. As you mentioned, we launched Warwick Agri-Tech as a joint entity between the Warwick Crop Centre of School of Life Science and WMG. Probably a lot of you are already familiar with the School of Life Science. So if you allow me, I will introduce WMG, what we do, in a very quick. So WMG is part of the University of Warwick, and we are specialists in moving technology readiness level from 4 to 5, meaning very industrial impact, a lot of development to make the thing happen from fundamental research to something practical and be ready to jump to the commercial states. We have a strong relationship. We are a multidisciplinary department based on engineering. We have more than 15 research groups, 850 people working in different areas of engineering. And WMG is also part of the Catapult Center, High Value Manufacturing Catapult Center. There is 7 different centers across the UK. We are one of the biggest one, and we have the capacity to create impact, social impact, environmental impact, and obviously mostly in industrial impact. We work around manufacturing, aerospace, automotive, energy. This has been our strong industry. So what we're doing now is try to transfer those capabilities and knowledge we have got from those industry into agriculture. It is not the same. It's a lot of challenge, and probably you more than myself know how difficult it is to tackle the challenge in agriculture. Different challenge that we will discuss today. WMG and Catapult is focusing in 5 different directorates, and together we're trying to challenge we're trying to tackle the challenge in the sectors. As you can see, they have digital, energy, intelligent vehicles, manufactured material, supply chain, organizational, and social transformation. So if we combine that, we can try to transfer these into agriculture. We strongly believe that we can make a change. but that was not enough. And when I'm saying not enough, the challenge we are dealing today in agriculture is bigger than just engineering. We need to combine our capabilities in engineering with plant scientists, with biologists, to make sure that we can deploy advanced engineering biology when it's needed. But the problem is bigger than that. We need to also include social transformation, medical transformation to tackle the challenge across the UK. There's different ways that we can engage. Probably at the end of the presentation, there will be some funding call opportunities, but with Warwick Manufacturing Group, we can engage by direct collaboration, direct contract. We can work together in funding calls, and we can bring our expertise of Warwick Agri-Tech with your company or with your ideas into something more tangible. So now I would like to, that's the introduction of what we do in WMG. Now I would like to start the webinar about in Warwick Agri-Tech, what are our motivations, what is our objective, what we believe that we can contribute in the sector, and also starting with what's the current situation and what we're looking at the moment, and how we can transfer from low tech to high tech. So just as an idea, we know, and I think we all are agreed, that we are overusing the planet already, and across the planetary boundaries that have been set by the EU, we are crossing planetary boundaries to get now to 6 different planetary boundaries, which is a big impact. It's a big impact because we're getting very difficult situation with the climate change, the biodiversity, the chemical flow, the water usage. So the situation is not easy, and I think you all agree with that. With the global warming, the climate change has impact in the crop production, its impact in how effective is what's the crop yield we are going to get. The average of the 2022 of the crop production is just the same than before, a little bit slightly below or what normally is the normal crop production, and that's mostly it's because the volatility and uncertainty is happening across the climate change. Now, if we move a little bit across the biodiversity has decreased by 68%. And if we continue with the same rhythm of producing food and agricultural practices, we will be expecting for the future a high reduction in insects that include pollinators. And we strongly believe that there is something that we need to do now. We need to act now to make the change. So the challenge is how we could produce the 50% more food that we need by 2050, keeping the stability of the planet, and reduce as much waste as possible without impact in our biodiversity. The challenge is very difficult, but that's why we need to start working with technology. And other agricultural challenge includes the water usage, and as I mentioned, labor shortage has been very important. And if now we move a little bit, something more specific about what's the challenge of the British farmer, the NFU has highlighted 3 main risks, which is around volatility, uncertainty, and instability. Volatility of the prices, uncertainty could be from what happened in the climate change, what happened around the world, what happened with the policies, what happened with politics, instability about we have a war in Ukraine, we have COVID. So the situation is very challenged currently in the market and currently in the sector. And I think one of the most damaged sector in the ultimate years has been agriculture. It's just because we need to continue consuming food. And we are very aware of the pressure of growers, because what we're asking to growers now, you need to introduce more technology, you need to be more efficient, you need to reduce pesticide, you need to be more productive, you need to reduce your waste, you need to continue producing food, and in the next years you need to be more green and produce even more food. And please keep the cost down. So when you put all of that and you try to mix all of that, the question is, how will I make it? If you can see, the agri-inflation is on the clouds already, and we have a problem with the labor shortage, we have lack of funding in agriculture, we have all the problem with the climate change and the production costs, because the consumer are requiring high quality of food, and the high cost of technologies, given the agri-technology is still already in development. So how we are going to make it? How we can, as I put in the position of the grower, how we could move from today's operation to the future of farming, how I can adapt my business to make it happen in the most cost-effective way. That's a big challenge. We also align with the government objective. I think you also know the strategy of the food by 2030 on the net zero by 2050 and how we can tackle biodiversity. We need to be agreed with that. We need to be aligned on what is required. And why? Because the economic impact of agriculture will grow, and it's expecting, if we can effectively address this market and bring the benefits that the technology could bring to this sector, we could reduce the benefit, reduce the costs in NHS. As you can see, bringing healthy food, it can really contribute enormous to NHS and all the malnutrition illness that are related. The agri-tech market is expected to be one of that they will grow the most, which are estimated global growth per year of 7%. This is massive. If we compare that the manufacturing is growing 1%, 2% maximum, if we're talking about agri-tech market, 7% is massive. So currently there's 1,200 agri-tech companies registered, and it's expecting that to grow massively. We in WMG work with a lot of robotic developers, and they are facing many challenges as the growers because they are looking for support in the sector, but this is growing exponentially. The question is, how many of those companies will really help? They will be effectively supporting the industry, how they will be capable to deploy cost-effective technologies to be capable to tackle growers, small growers to large growers. Based on the statistic of DEFRA, the last one that's been published, 8 to 10% of the growers can produce 50% of the foods in the UK. But there is 200,000 growers registered in the UK, farmers that include livestock, obviously. So we're talking about a massive quantity of farmer growers that produce the other 50%. So we cannot be in an industry that the technology will be just for the large companies or medium large, need to be across all of them. But what the challenge here is how we are effectively can introduce this technology cost effective for tackling the application and use case for the small growers or the small medium growers, because probably it could be different in terms of the scale to the large growers. So that is other areas that we are looking to better understand what are the needs at the different scales. So what we can offer in Warwick Agri-Tech. So we're looking to deploying high-tech advanced biology research in the area. And we, as I said at the beginning, we strongly believe that it's not about engineering. It's not about now. It's not only about biology. They need us. We need them. And this is how we are collaborating in a few projects that we are going to talk later. And probably they channel at the end. We also conclude the needs to be collaborating in this journey to support the industry. We are here. Warwick Agri-Tech is all about collaboration. It's all about supporting growers, supporting industry, and support the supply chain. We are not looking for developing the novel, super novel technology just to have a research. It needs to have an industry impact, and at the same time be innovative, and at the same time tackle the challenge that we want to address. So it's multiple things. It's not only just create a technology just because. We're looking to increase the productivity, decompress the food supply chain that we know is already under a lot of stress, and introducing automation, robotics, AI-driven under a cost-effective and sustainable solutions. As I mentioned also at the beginning, the University of Warwick and Warwick Agri-Tech has more than 800 staff working together with the crop center. 220 hectares at Wellesbourne. We manage a large portfolio of partners that we can easily bring in a consortium to work with other industry, with other growers, and we also work across the other agri-tech centers like Agri-Epi. We start discussing with them, CHAP, and Syngenta, etc. So there is a lot of opportunities that we can bring by working with growers to help crossing this bridge of low tech to high tech. And we made an analysis last year to try to show with numbers, we love numbers, how WMG and Catapult can help business. we did this with manufacturing, but we can do the comparison to agriculture. So we estimated that every time that Catapult and WMG do an intervention, the estimated cumulative value added that we can add to the company's business is £600,000 in the following 3 years after the intervention. So if we can really create a penetration in the agri-tech market, that we strongly believe we can really add a gross value added of 35 million in 3 years. And it's just considering the existing technologies, but there's a big chance that with WMG and School of Life Science, we can go deep and increase the level of technologies and bring in more developers to create more impact. And we really would like to contribute on doing that. The capabilities we bring in, as I mentioned, is engineering biology, but also very focused on the industry, very focused on the government, and also academia. We need to have novel technologies. We need to tackle the challenge. We need to understand the problem from the government, and in that triangle, developing the novel solution that we need to put in the market. The capabilities that we do in agri-tech are related with robotics and manipulation. So everything with robotic arms, manipulation, and effectors, perception, sensing, cameras, all the type of sensors, artificial intelligence, machine learning. I think we strongly believe that the 3 first capabilities are making a big change and shaping the future of farming. Automated and connected farming, data analytics, digital system are not related with autonomous vehicles. Could be drones, could be autonomous mobile vehicles, etc. We are combining these with the expertise of a School of Life Science, which is crop improvement, precision breeding, smart crop protection, and everything in agronomy, epidemiology, crop pests and diseases, very important. We know that globally, we lost 20 to 40% of the crop are lost because of pests and diseases. So you know how difficult it is to, I think if there are farmers today, they know how difficult it is to increase productivity effectively. Sometimes they need to plan ahead and plant more than what they're really going to harvest, but that produces a lot of waste. So how we can reduce waste, that's a big challenge. It's not only about producing more, it's also about how we reduce the waste. That will create a good margin profit and reduce all the stress we're putting in the planet and sustainability aspects. We target these sectors. We are not targeting livestock in Warwick Agri-Tech, and our vision is to secure the global food system and reduce as much as possible the impact of the human intervention in this challenge to produce more. We need to keep the stability of the planet, and for doing that, we need to deploy advanced research and automation, robotics, AI, and plant science. Our strategy is moving from funding the strategy until understanding the needs, and I think hopefully after this session, I will be more than happy to share more thoughts with anyone, and especially if there are any growers today, about how we can go from looking for the funding, work on the strategy, how we can build a strategic plan, how we can understand in the industry, how we can bring technologies. I will be more than happy to work with all of you if that's needed. The area of action, the action we have to our action point or action plan is to work across crops and supportive systems. So we have the big goals, or the ultimate goals we have in Warwick Agri-Tech is to understand how the greenhouse the future will look like. Can we deploy a greenhouse in anywhere? What's the need? What's the sustainability aspect? How much water we need? Can we put a greenhouse in a desert or in a very cloudy area? What will be the implication of the plant? How the automation will be required? Is the greenhouse today made for automation, for robotics, or is made just for human, like old-fashioned greenhouse? What will be the changes? We don't have the answer now. We are working for that, and we are in every single project we put there. We're trying to get the conclusions to understand. Okay, for this project, that will be the digital system we will put in let's kind of, as an example, crop protection project. We will understand what will be the implication of the AI model, and that AI model could be a digital system, and then we start getting conclusions, and those conclusions will help us to say, if we do this differently, if we rethink agriculture, this is how it will look like. Okay, let's try. And we have amazing facilities at Wellsbourne that we could do that, and we have enormous skills in engineering to make that happen as well. And on the other hand, is to understand the future of agriculture as a living factory, how it should be as lean as possible, how we can make a smart agriculture. But there is something that is important to mention. All this decision is to support growers. In Warwick Agri-Tech, we are not here to replace the human intervention or the experience of the growers, because that is very important. It's how we could create system to support them in the decision making, how we could create system to help them to tackle the labor shortage, not because we don't want to replace people. And I want to make that statement very important. We are not helping robotic developers to replace people. What we are doing here is to try to cover the bridge, because currently it is not possible to recruit people, and we need to still continue producing. How we are going to do that if we cannot find people on doing that? So that is our motivation. And in the areas we're trying to tackle is around crop protection, crop health, precision planting, harvesting, soil health, etc. And supporting these two main goals with the intralogistics, how is the biodiversity, how we can create autonomous and connected operation. All of this is supported under the understanding of having a resilient, sustainable, affordable and nutritious agriculture. And also to build an efficient food production supply chain. Is the current supply chain good enough? Is the current supply chain the only one we need in the future? How about local supply chain? How about the transportation costs, the transportation footprint? So it's many things that we are already discussing. I also would like to share with you a few of the projects we are working. Probably the videos will be difficult to see because the lag on the connection. So I apologize for that, but it will depend on the internet. And I would like to show here some example of intralogistics, some example of introducing sensors. This project we work with another grower in Valle Fresco, and we have the project where we also try to introduce machine learning with, as you can see, some manipulations systems and N effectors where we can understand the ripe level of crops. We started with the strawberries, but we believe that easily we can escalate to other type of other type of crops. As you can see in the image at the top, we are using our robot. We built this robot in-house, and our robot to interact with human. So that will be the future, because that's important. Robot and human. Will the robot replace human? My strong answer is no. We need to find the right point and balance to say this will be automation, this will be human collaborating together in the most efficient environment. And so to make that happen, we need a lot of sensor around, and that project was effectively try to understand what is the digital system and the automation we need to put in place and to make that happen. We also working in forestry. This is just an example of how we could do to moving from digital virtual model to something more real. And using AI and computer vision system is massive. We can understand the sizes, the motion, we can understand the key point, and then we can understand how we can introduce the automation and the points required. And we also looking for understanding automation data to collect. We're working in a project with wheat, different species of wheat, to try to understand developing 3D models, etc. I'm not sure how good will be this video. Is very short, but that can also highlight one of the system we are putting in place in one of our lab. I know it's difficult sometimes to go to WMG if you want to go, but this is one of the systems we put in place. And what we're trying to do here is to automate the grading systems and up to forestry. We strongly believe that by helping growers to plant more trees, not only will help to the carbon sequestration and productivity in the sector, but also will help to bring biodiversity, to help to create more wild ecosystems to the voiceless, which is the insects. They cannot say we need more habitat. I will go very quick. So we also training our system at Wellsbourne, where we are collecting data from the weed species, and again using machine learning in our team to understand and create the models required. I think that should be enough for that. Another project we're working is called an integrated crop scouting system. We are looking to identify spider mites. This is the first project we are working with insects. I'm an engineer, so I think it's fascinating. Try to understand the motion, try to understand the behave, and how we can put a system to try to capture what they do, the damage on the leaf, the population underneath the leaf. So we are in that journey now to understand what's the most efficient way to allocate camera, to allocate a robot with the sensors, how we could capture that data, and how we could then build a model, an AI model, a machine learning model, to collect the data, understanding what exactly is happening in there, and then translating that data to something useful that can be an input to the integrated pest management that ultimately will say to the grower, we have a problem here, we need to act now. That's all about. That's all about. So we are in that journey. We are working with the School of Life Science with my colleague Dave Chandler, and we are doing also a collaboration with BioVest to try to tackle this problem. It will be our initial use case, and we're expecting to try to, with this experience, moving into more pests and diseases, which is very required nowadays in the sector. My last slide, and then I will pass it to my colleague Dave. We went through the different challenges and also what's happening already with the need to tackle the challenge and support growers, working with the government in the future objective, the food production, the planet stability, and sustainable practices. And in Warwick Agri-Tech, sorry, we have the challenge about how growers can become a high-tech and efficient business and move their operation into the future of farming. We are going to deploy during this year an Agri-Tech accelerator program in order to support the growers to accelerate the transition from current technologies to high technologies. We would like to help them to create, implement, and coaching a roadmap package, which will include technology, what could be the best technologies to adopt based on my current businesses, what should be the strategy and the leadership I need to put in place, what could be the best practice in the crop management system that need to be linked with the current technologies, how that will match with the financial roadmap and return on the investment, and how could I implement this? What should be my funding ways? How we can make it happen? So we will contribute, and that will be a 6-month project program. And this is just starting. We are going to do this in collaboration with NatWest. So this is something that will happen. I wanted to share this with you today. It's still in development, but we hope by April, May, we can have more news, and hopefully you will like to join. We understand that there is a lot of need to scale up the business, understanding the return on investment, how the technologies could help to the business, to the return on investment, but we need to understand how effectively they will help. It's not just not to allocate a robot just because, how that will help, how much it will pick, how many robots I need, what will be the combination between robot and human, what skill I need to put there, because it will be a robot, I need an engineer, how much it will cost me, how much I will produce, how much I will reduce waste, how mature are current technologies available, what is the fragmentation in the different technology readiness level. So all of the things we would like to work with growers to try to reduce that uncertainties, and try again to work with you to tackle the challenge we have currently in agriculture. So I think that's been my participation today. I will jump into my colleague, Dave. Thank you very much.
Many thanks, Emilio. If anybody's got any questions, please put your hand up, your virtual hand up. Happy to take questions now, or you can type any questions in the chat. looks like no questions so far. Yeah,
Yes,
I'll hand over to Dave Chandler now.
I've got a handful of slides. Emilio's gonna, if I shout at you, Emilio, then you can. Okay, so do you want to go back a couple for me before I start? So I wanted to kind of give the life sciences perspective about agri-tech and the opportunities to combine advances and developments in engineering with advances and development in the life sciences, and specifically with respect to the opportunities we can use to improve fresh produce and horticulture generally, but kind of widen it out to agriculture for the UK. So WMG are really interesting because they work with a wide range of companies. They have world-class expertise. You know, they're working with Airbus, they're working with JLR, they're working with Ford, they're working with Tata. We have a Ford Mondeo that drives around the university campus that's completely autonomous. We have a wide range of expertise that we think we should be applying to new developments for agriculture and horticulture in particular. And so there are huge opportunities there. So Amelia, do you want to just click on the button for me? So this is kind of reinforcing some of the stuff Amelia was talking about beforehand, but we know there are some important external drivers that are affecting horticultural production in the UK. That includes climate change, the global environmental crisis, issues around food security, labour, energy, you know, the need for healthy, nutritious food, and the need for high-skilled jobs in agriculture. But we have this thing that underpins it all, which is the development of new technologies, which, when combined together, can really see some major advances in agriculture and horticulture. And I think it's this combination. You often make the biggest jumps in any discipline, in any challenge area, by combining different things together. In this case, there are new developments in engineering, such as automation, robotics, AI, which are the things Emilio has talked about, and there have already been some very big advances in that area, but also big advances in the life sciences. So we've seen big advances in the development of biological crop protection, in plant breeding using gene editing, in understanding the role of the microbiome in plant health, and in applying ecological principles to agriculture. And I think when we combine those things together, we could see some really large advances to help us achieve increased sustainable production. So can I have the next slide, Emilio, please? So I'm just going to give you some examples of where I think the opportunities are, and this comes from my perspective as an entomologist and as someone who does a lot of work on kind of biological control and quite a lot of work in protected crops. So the first area is about precision application of bioprotectants, or biopesticides as they're called. So we know that there's increasing pressure on the use of synthetic toxicant chemical pesticides, and their availability is declining, and also there'll be an increasing number of biological crop protection agents coming onto the market. And the thing about biopesticides is many of them have contact action. They're not forgiving, in the sense of if you have a conventional chemical pesticide, if you miss the target slightly or you don't get the right dose, they'll still be effective. Whereas for biopesticides, you need to be able to deliver the effective dose, which is often quite a high dose. You have to hit it at exactly the right place and the right time. We also need to move over to low volume or ultra low volume application for biopesticides, because many of the water volume requirements on the label at the moment are really high, and applying a high water volume is very inefficient. So if we could combine our knowledge about biopesticides with automated precision robotics based application systems, we will be able to deliver this new class of crop protection agents at low volumes to the right place and the right time. So I think that's a really good example of how engineering can facilitate kind of advances and increased uptake in our kind of biological control systems. Can I have the next slide, please, Emilio? So this is an example which kind of follows on for the biopesticide stuff about combining agri-tech with integrated pest management. This is on spider mite. So can I hang on a minute? So we did work some years ago with Rob Jacobson on spider mites, looking at kind of a biphasic, if you like, IPM system. So this is on tomato crops. So we can know that we can get good control of and a standard method of obviously for spider mite control on tomato and other protected crops is primary kind of baseline biological control with predators, but there's often periods in the season where the spider mite starts to outstrip the ability of the predator to control it, and then to get things back into kilter you need to come in with a fast acting supplemental treatment. And in the past that used to be done through the use of synthetic chemical pesticides, but we showed that you could actually do the same very effectively using a biopesticide, in this case an insect pathogenic fungus called Bavaria. And in fact, in the experiments that we did, the fungus outperformed the standard chemical treatment at the time, which is subsequently that standard chemical treatment has been banned. So we have a nice kind of IPM system with primary biocontrol by predators and then our biopesticide, fast acting biopesticide as a second line of defense. And you can see that that could fit in really nicely with developments in automated crop monitoring using images, using biosensors to supplement the work of the agronomist and to give them additional information to identify where you're getting pest outbreaks within the crops. Can I have the next slide, please, Emilio? And then that can then feed into a decision support system. Next slide, please. And then that goes into inform our precision application of biopesticides. So it's this combination of biological knowledge, in this case, kind of a biologically based IPM system, with getting additional information to make the work of the agronomist and the crop protection specialist a bit easier. And with those systems, you can easily see that your decision support information will go direct to the grower on a dashboard on their, on their smartphone. So these are the kind of areas that we're actually working in already. Can I have the next slide, please? So this next example is about, again, it's protected crops, and again it's tomato. It's about climate change impact, and it actually relates to some AHDB work that we completed recently with grower partners, looking at the impact of climate change on tomato crops. So we know climate change is impacting on crop production around the world, and it's going to have, I think, a big impact on protected crops, because in the summer, even in the UK, it's getting too hot during certain periods of work, certain periods of the year. So we did work showing that tomato flowers are really vulnerable to increases in temperature, and specifically, if you've got a picture of the flower there, the pollen mother cells that were within the anther cone as the flower is being formed when it's a young bud, those pollen mother cells are very sensitive to increases in temperature, and a temperature increase going up to 30 degrees C between 7 and 13 days before anthesis, that's sufficient to actually kill the pollen mother cells and stop the plant producing pollen in that flower. In fact, some growers think that the temperature threshold is less than that, and it might be as low as 26 degrees. And when you get inhibition of the ability of the flower to produce pollen, then you can get mis-setting when the fruits don't actually form, and that's a real issue. And in some cases growers have kind of reported during hot periods up to 20% losses within the crop. Next slide please. So at the same time in the UK on tomato crops, we have growers now being required to use the so-called British native subspecies of bumblebee for pollination, Bombus tressus audax, and we've shown that it has relatively poor intrinsic performance, by which I mean pollination is likely to be suboptimal with BT audax unless the grower is on every single factor, and that could include things like temperature extremes. And so we have a situation in which climate change is going to be impacting on the ability of the flower to produce pollen, and also climate change is going to be impacting on the ability of the bee to perform its pollination services correctly, and those two things are going to interact together. So what we need is to be able to use new technologies to give the grower better advice and better information, and rather than monitoring the temperature, the ambient temperature in the house, we need to be now monitoring the temperature of the leaf surface and actually within and at the level of the flowers. And again, we can use, and we're starting to work towards that. There are lower cost temperature sensors that you can put into a house as part of an array or part of some kind of mobile platform that would again give data directly to the grower. Can you click again please, Emilio? And then that can feed into a real-time decision support system for the grower, again to a platform on your smartphone, and it will just tell you, yeah, temperature's too high, it's past the threshold, and it's likely to be causing plant damage to the flowers, and then the grower has to intervene. In this case would actually be cooling the house in some way. So you can hopefully, I probably haven't explained it very well, but hopefully you can see it's that combination in this case of understanding kind of crop physiology, understanding entomology, and using technologies to the grower and to the agronomist to get them better information to take faster decision making. And then I think, and one more slide, actually, this will be my last slide, Emilio. So the kind of the key points and summarising what we think we can actually do in this agri-tech, which is bring in engineering expertise alongside with kind of expertise in horticulture and in biology. I've kind of bullet pointed the various things here for you. So what we would like to achieve in the future through kind of this agri-tech enterprise is first of all to de-risk technologies for growers and for the kind of nascent agri-tech industry that has been developed at the moment, and universities have a big part to play in that. I think in the UK we need to be working together, so engineers working together with life scientists, working together with growers in the UK horticulture industry, and also with, as I said, these new ag tech companies that are starting to develop at the moment. The challenge for us all is to be able to make new advances in engineering that work and which are cost effective, because there's no point having something if it's so expensive, a grower's never going to be able to afford to use it, and to be able to use it to increase their profitability. We need to be looking at a global market, because the things we can develop in agri-tech are not just relevant to the UK, they're relevant to the entirety of the world. And in order to tap in and capitalize on that global market, then we need to be developing a kind of a UK network, and as part of that we need an industrial strategy for the UK that includes horticulture and has kind of sustainability principles that Emilio outlined at the beginning embedded through it. So that's it from me. Sorry being quite quick, but that's all I wanted to say about that.
Excellent. Many thanks to both of you. We've got a couple of questions in the chat. First of all, Alexander asked a question, and I know Alicia put a response in the chat. Alexander, do you want to ask anything else, or is that okay? Oh, gone. Right. Okay, and then Gary's also put a question in the chat. Gary, do you want to ask the question?
Sorry, Rosemary, something had a challenge with my mic there.
Oh.
Yeah, no, thanks. I picked up the response. Thanks very much. I'll follow up on that.
Excellent. Okay, thank you. Right, so over to Gary. Gary, do you want to ask the question?
Do you want me to read it out? Yeah. So what Gary is saying is about the challenge of pest and disease monitoring, and a particular challenge about being able to detect a very small infestation which can rapidly become a hot spot. And he says, your thoughts, please. And yes, I agree with you, and it's something I've kind of thought a lot about recently, because the probability of, say, detecting a small number of aphids within a crop, or 1 or 2 spider mite eggs within a crop, that's a huge challenge, and it may be impossible to detect just a small number of aphids in the crop. And I think the way to approach that is combining your technology within the integrated pest management pyramid and framework. So if we take protected crops, then we know that preventative biological control can be very effective to reduce the outbreak of a pest population in the first place. So that's really important. But as I was saying in the previous slide, there are always occasions, if you're using a preventative biological control release, when the pest population will start to go past your threshold. And that's when you need to come in with this supplemental treatment, which can be a biopesticide. But then having a monitoring system that is able to look over the entirety of the crop and supplement the work of the agronomist is really useful, because there are fewer and fewer agronomists available. So an agronomist may only be able to look in the crop once every 1 or 2 weeks. And so being able to get remote information could be really valuable.
Sorry, Dave, maybe I can also try to complement something. I think monitoring crops, it's a very complex task. I strongly believe that the complete solution should be a combination between automation and human. So there are few aspects on the crop walking or crop checking, whatever you want to call it, that will be difficult to do and complex and expensive for automation. And I strongly believe that there should be, the comprehensive system should combine human and robot. So where robot can do like the standard actions that we could get there, but it will be a point where we will need the agronomist to manage different type of systems. There will be probably other humans, there will be other robots and systems together to get the final outcome and the final conclusion of what's happening in the greenhouse. I believe that to get to the point where we'll need 100% automation, fully autonomous for everything, it will be very complex. At the moment, we should try to understand what's the best combination for a cost-effective technology between human collaborating with robots.
Yeah, exactly. And so you might get the situation in which you can use monitoring system that says, raises a red flag and says, we think there's an issue in this part of the crop, and then the agronomist goes in and it saves some time, and they look and they find exactly what the problem is. That's the kind of thing we're thinking of, rather than some all singing, all dancing system that says you've got 1 spider mite egg and it's on the 3rd leaf from the top in the middle of the crop. That's impossible. But as Emilio said, it's all about the technology working to make the life of the agronomist and the grower easier.
Yeah, I think will be a path to get to the fully autonomous stuff. At the moment, it will be that collaboration. I think, for example, for that type of use case, augmented reality will be very important, especially because you can use augmented reality remotely. So you can have a team of plant science supporting the agronomist from the office in a glasshouse that will be in Australia, and you will have a team of engineers at WMG on technology developers in the UK supporting the same team in Australia, and you can use all of that with augmented reality. So that's how you can use the technologies and the AI system, the robot with the human at the same place, and that will bring more benefits and more outcome, because will be a better decision, a more informed decision to make. So that type of ideas it's already happening, but we will still few years to get there, and very effective and cost effective, especially cost effective.
Yeah, exactly. And the point, I think the background to a lot of this is that we don't have enough agronomists really to meet demand at the moment. So anything we can do to make their job and the growers' job easier and better and more effective, and make faster decisions and better evidence-based decisions using technology, then that's the kind of thing we should pursue. But I agree with you, we have to be realistic. We shouldn't promise something that we can't deliver. That would be wrong. But what we're trying to do is say, okay, how can we use technology just to make things easier? But that's why we need is a proper partnership. Part of the reason for doing this webinar is that we really want, input from the experts, from the growers, from the agronomists, from people like yourself, Gary, so that we can all work together to find this way forward.
Yeah, I'm not sure if there's another question, but in the meantime, I also would like to probably encourage that there's different level of technologies. Sometimes I've been discussing with companies that they believe that agri-tech is just for complex technology, and that's absolutely not the case. So we can go from very simple technologies that will impact in certain processes to something more complex that will be like AI models, things like that. But agri-tech is all about introducing this engineering approach to where everything that could help. So even if you have an idea that could be very simple, that is also part of the problem. So it's not only about complex situations, it's all about how we can make the process lean, how we could reduce the risk, how we can mitigate action, and introducing certain type of technology. That can be a very cheap sensor to collect data, and then we can integrate that data in something and in a spreadsheet, an Excel spreadsheet, and that could be enough to maximize certain output. And that is also part of agri-tech, and that is very simple, very cheap, but the importance to automate certain data, the collection of data, is massive. It's massive because if there is, I'm not sure if there are any growers today, but if there are growers today, you see how difficult it is to be collecting data every day. And a standard and a different shift. So it's collecting data is not the most exciting thing to do, and that's why we have automation technology that are very, very cheap and easy to implement.
Great, thank you. So we've got just a few minutes left. If anybody else wants to ask a question, or if anybody else in the team wants to make a comment, then please shout now.
The only thing I'd kind of say to finish off with that, we really want to, we have a very long history of working with UK growers and a strong partnership, and we really want to take that forward and bring in people's ideas, knowledge, expertise from the horticultural sector, and then see how that that can feed in to modern advances in engineering and apply those to the industry. I think if we can do that and work together, it's going to be really, really super exciting. There's lots of opportunities, I think, ahead.
Excellent. Many thanks, Dave. So yeah, looks as if there aren't any more questions. I'd just like to thank both of you, Emilio and Dave, for your presentations, and to everybody who joined us this afternoon. We will put a recording of this on the website and send you the link to it, and we'll also send out information about our next webinar, which will be in February. So thanks very much for joining us, and hopefully see you at the next one.
Thank you very much.